and I use the term loosely. Welcome back to the shop this morning. I'm going to give you a little update where I'm at with a couple of projects, show you what's going to go on, and let's get started anyway. This is a crankcase I've been working on. There were cracks through here that showed on the inside. They were kind of welded on the outside. So what I did was I took a Dremel tool and I ground them all out so that I could get way down in there. This is all going to be filled with weld. Where the drain plug hole was previously welded, you know, it only had a little bit of goop smeared on the outside of it. We're going to fill that all in with weld. There was a crack that goes through here out to the edge of the crankcase. We're going to fill that all in. The crankcase had been filed a little bit in through here. We're going to lay a little bead of weld on top of that and eventually file it down and get it, you know, flat up against the other side of the crankcase. We're going to get started on that in a little bit. We're going to do one other little project on this crankcase. Here it is. Okay, this owner has decided that he's never going to use the transmission Speedo drive, and he wants to plug this up to prevent leaks and help reinforce this area. These crankcases, these 900cc crankcases, are notoriously weak all through this area, and if anything goes wrong with the trans, it usually blows this corner out. And you know, part of the reason is you got a big hole over here where there should be metal. So what I do with those that I plug is I just machine a little aluminum plug, stick it in there, we'll weld that all the way around. This is one part of the reinforcement. We're going to flip this over and I'm going to show you what goes on the inside of the crankcase. Okay, this is the other area that is weak on these things, and you can see the boss around the countershaft is not very thick. On the 1000cc crankcases that do not have the Speedo drive in this area, this metal here is about a ½ an inch thick. It's really beefed up, and I run into a lot of these, and I got another crankcase I'll show you on. These crack, they break out. So as part of reinforcing over here, I'm going to machine a steel ring that is, the inside diameter of the ring is going to be a little smaller than the outside of this boss. But anyway, that's going to be the part B of this reinforcement. And with that ring around there, this thing is not going to crack. And even if it does crack, which is really unlikely after it's reinforced, the steel ring is going to contain the crack and keep everything lined up over here. So it will help prevent the bottom corner of the trans from blowing out. I'll show you that when I get around to making the parts. Men, if you remember at the beginning of this video, I said I was going to do this, that, and the other thing, video it, and put together a video of what I did that day. Didn't work out that way. I don't remember what happened, what went wrong, what took so long. I don't remember. But anyway, it's a week later now. And eventually I did get done with most of the things I said I was going to do, I think. Crankcase is welded up. The hole is now welded over on the inside. Everything has been dressed down, sanded, ground. The flywheels, well, when you weld on the inside, it builds up quite a bit, and it would hit the flywheel. So that's all been ground down to match the contour of the crankcase. I built up the right-hand crankcase with some weldment. I filed and sanded it down, and I used to be able to shove a 4,000th feeler gauge all the way through there. I got 1,000th and a half, and it just kind of barely goes in, and that tells me there might be a little bit of crown on this surface over here, but I've got metal to metal contact all the way around on this thing, so I'm happy with the way that worked out. You know, like I said, I could barely get 1,000th and a half in, just a tad along this edge. So you know, and as you recall, in the middle over here, I could get a 6,000th feeler gauge all the way through this thing. So I'm happy with the way this worked out. This is going to seal up just fine. I'm not concerned about it at all. So that's done. I'm going to open these cases up. I'll show you what is going on the inside, and we'll take a look at that. Stand by. Okay, so here's that right case opened up. Here's the mating surface, which has, you know, all been dressed down, sanded and filed smooth. You might recall where the drain plug was. There was a crack that went up and through here, obviously all filled in. If I get the angle right on it for you, you could see where my welding filled in the hole and the you know, the area that I grooved out with the Dremel tool. So that's all taken care of. I also ran a what I call a dingle ball hone just slightly through the pinion shaft race just to clean it up, and I also ran a dingle ball hone lightly through the main shaft bearing race just to clean it up. And here is the reinforcement. Let's see if the angle is right on that. Yeah, that looks like the angle's right on it. Here is the steel reinforcement that I made for the counter shaft. This steel ring is about 3/1000ths of an inch smaller than the outside diameter of this boss. It's a fairly snug press fit. It's held on with a green sleeve retaining grade Loctite. It ain't going nowhere. Now, of course, the trouble with this is the transmission speedometer drive shaft extended into here. Well, the hole is welded shut on the other side. There will never be a drive here. And of course, this ring is in the way. This ring is also in the way of the worm gear drive on the countershaft first gear. Let me get a hold of one of those and I'll show you what's going on. Okay, so here is on a 900cc Sportster, this is the countershaft first gear. And this is the worm gear that drives the Speedo drive. And this ring is exactly in the spot where that worm would go. So this gear will no longer work anymore. What I have done previously is the worm gear is pressed onto the drive gear. Is you can pull this off and then I grind down the flange that the worm gear is pressed onto. However, these gears with the flange and the worm on them are getting kind of hard to find. So I no longer like to destroy these gears because you know, I might have a 900 where I need a good one of these, and I don't want to destroy this if I don't have to. So as it turns out, the 1000cc gears, the 1000cc gears are exactly the same except for the flange for the worm gear drive. So no need to destroy this gear. I'll use one of these. So this gear will fit nicely up against there. It will butt up against there nicely. The thrust washer goes in this little recess over here. The thrust washer will sit on the edge of this aluminum boss in this area. So there will not be steel to steel contact between the thrust washer and the steel bushing. And I made the steel bushing a few thou shorter than the aluminum boss. So the aluminum boss stands proud of this surface by about 3 or 4/1000ths of an inch. So anyway, that's going to be the reinforcement job on this thing that I wanted to do. Any of you guys watching this, I mean, obviously you're watching this because you're interested in old Sportsters and you need this done. This is a fairly cheap proposition. It only takes about 3-4 hours of my time to do the measurements, make the part, and install this thing. So hey, if you guys want this done, shoot me an email. And you know what? Feeling generous, subscribe to the channel. I'll do one for you for free. Let me get you an old crankcase and I'll show you the problem that this is designed to prevent. So here's another set of 900cc crankcases, and if you look down in here, you could see the problem that reinforcement ring is trying to prevent. I got cracks over here, I got a crack over here. It's hard to see on camera. See if I could tilt it a little bit, maybe. Well, it's hard to see, you have to take my word for it. But this crack spider webs out in through here. It goes a couple of different directions. This crack kind of spider webs out in here. And this crack and this crack are moving together. And if I took this chunk and whacked it with the end of a hammer, I think it probably would break off. But anyway, this is the problem that I'm trying to prevent with that reinforcement ring. Now that this has been cracked, I don't think there's any point in putting the reinforcement ring on there. It would be at best a band-aid, because I think what will happen is if I reinforce it out here, I think that's just going to make the whole thing break off. I think is what's probably going to happen, because it's starting to starting to, you know, spiderweb out around this circumference. Now this is actually fixable. What I've done on other engines that I've run across that have cracked the same way is I'll put this on my milling machine, I'll locate the center of this hole, and then I'll just mill all this material out of there. I'll machine a chunk of billet aluminum with a hole in the center size for the bearing. It'll be about the thickness of this this dimension here, and I'll mill this all out of there, machine it all out of there. After I machine my part, this material, of course, will all be gone. I'll put my repair part in here, and it'll be chamfered. I'll chamfer the crankcase, chamfer the repair part, and I'll weld it all the way around. That part will be the thickness of this dimension right here. And then on the inside of the engine, I'll have it sized so that I could weld it across here and weld it across here to give a little extra reinforcement. So that is repairable, not easily, and that gets to be pretty time consuming and pretty expensive. The $200 steel ring repair is cheap. Doing this, you know, milling and reinforcement and machining on this, you're probably looking at several $100s by the time all is said and done on that one. But anyway, this crankcase is going to be another video later on, another project. It's got a crack missing over here. It's got this part that's broken out. Flip it around to this side. You got a rear motor mount boss that's broken off. You got a little chunk broken off of here. And then kind of an interesting thing, this owner must have suspected a problem, and he went and peened this area of the crankcase, all these little dots, to help retain that bearing that was in there. In the long run, that of course is not going to do any good whatsoever. It'll fail on you eventually. Okay, and then, well, later in the week, and I don't remember when exactly or why, but I ordered a bunch of parts for this 69 I'm working on, and when I was ordering parts for that, I ordered extra sets of connecting rod bearings. So I said I had all these old rods laying around. Turns out I have 3 full sets of Sportster rods. I have one female rod, and I got I think a set of panhead rods that I haven't done anything with laying there. But anyway, I fitted new main shaft bearings to all of these. And I'm not going to name the manufacturer of the bearings, or the bearing races rather. I just will say that they are American made. And the problem I have with them is every one of these sons of bitches, even though they were listed as standard, turned out to be 0.010 of an inch oversized. You know, I don't know whether bins were mismarked or whether they just make them 0.010 of an inch oversized. But anyway, if you try to stuff something that's 0.010 of an inch oversized into a hole, the chances are something's gonna give. I don't know. I suppose it could crack the rod, maybe. It's going to be an awfully tight press fit, a lot tighter than it needs to be, or you want it to be. So what I ended up doing was putting these all on a mandrel to hold on to them, because of course you can't hang on to them. And I have a tool post grinding wheel, and I ground the outside diameter of these down a few thousandths of an inch, so these are all now fit with about a 4/1000 press fit. And once again, that green sleeve mounting Loctite, grade Loctite, these are never coming out of there. But anyway, 3 full sets of rods, a half a rod over there, all with new main shaft or with crank pin races in them. The wrist pins, there were, let's see, there was 1, 2, 3 of them that were totally, completely no good and needed to be replaced. So 3 of the rods have new wrist pin bushings in them. They've been reamed, they've been honed to a standard piston pin. The ones that I didn't replace are all just fine. So hey, you need a set of connecting rods, go to my website, shoot me an email, send me a text. You know what, and this is, once again, I can't believe I'm doing this. Get me to 100 subscribers and I'll give away a set of these if you need them. Anyway, that's that part of that project. Let me show you what else is going on in here. Okay, on my welding cart, there is a new Miller Dynasty 210. The Econo TIG worked just fine for a long, long time. This welder's got 50 more amps capacity output, all kinds of things you could do with it. Adjust frequency, adjust the length of time, positive and negative. You could control your cleaning action, depth of penetration, control your arc a lot better. I haven't even well, I've turned it on, but I haven't welded anything with it yet. That might be another video. I'll let y'all know how it works when it gets going. Okay, now moving on to my bike. Project Y, I think is what I call this one on my website, the orange machine. The exhaust pipes are not on it. They are all welded. The welds have been all ground, sanded smooth, contoured. It's got nice little upsweeps on the end of them. I think they're really nice, better than what was on there before. Right now those are being ceramic coated at a place down the road for me. It should be done in a week. You guys might recall from an earlier video, I talked about making this cover. I got rid of the stock Harley sprocket cover and made this. This is much heavier material, 1/2-inch aluminum. It's all polished out now. I've got a extra mounting bolt over here to help distribute and carry the load a little bit, the load from kick-starting it. So I think this is going to hold up better than the old ones do. As you also might recall, I did not care for the nasty looking nut and the nasty looking bent tab lock ring that goes underneath this thing. So I managed to find a stainless steel nut that was almost the right thread size, that I was able to cheat into matching the threads on the main shaft sprocket. But anyway, it has on it the backside of what I believe is a Kennedy $half, as I seem to recall anyway. And the nut is stainless steel. I wanted stainless steel because it's durable, it holds up, it's got a nice finish on it. It's quite a trick to get anything to stick to stainless steel. This nut had a recess machined into it. Into that recess there is a brass disc that was silver soldered into the nut. After the brass disc was silver soldered into the nut, I tinned it with regular solder. I tinned the face side of the coin with regular solder, laid the coin on the nut, heated up from the back, and the two solders flowed together nicely. You can't get regular solder to stick to stainless steel. Stainless steel repels it. You have to use silver solder on it. So this was quite a trick. This was really kind of a pain in the balls. Anyway, to get rid of the locking tab but still retain a locking feature, the sprocket has 2 holes in it for a gear puller. Put a screw in one of the holes, drilled it for safety wire, drilled a hole sideways through one of the flats on the nut, ran some safety wire in it, so it's safety wired on there. I'm really happy with that. I like it a lot. Anyway, the exhaust pipes should be done next week. They're out being ceramic coated right now. And I got a thing about chrome. I don't like it. Chrome is not particularly durable. My new pits in it pick up rust. It peels off, it flakes off. I don't like chrome. Give me the natural metal surface, polished whenever you can. If it's steel, it's going to be black, probably, in my world of doing things. And that's just about it. As a matter of fact, you know what? I think that's all I have to say for this video. No, you know what? I'm going to say one more thing. Stand by. So here's the last thing I'm going to say today. These crankcases are ready to be bolted together. The reason they're not bolted together is because the cam cover is out at my chrome place, having the chrome stripped off of it. The chrome was all fucked up, and you just heard me expound upon how I don't like chrome. The chrome was all fucked up. Chrome is the kind of thing, if it isn't perfect, it's pointless. And you can't keep it perfect for very long. But anyway, as you may recall, one of the cam bushings was binding, which was one of the reasons this motor was hard to turn over when I took it apart. So because what I'm going to have to do is put the cams in, bolt the cam cover on, make sure they rotate freely. I know there's at least one that has to be line reamed with the reaming tool. The reaming tool goes in from you know, inside the engine. So until I bolt the cam cover on, put all the cams in, make sure the bushings are all good and lined up, I can't bolt the crankcases together. I'd like to bolt them together just to get the parts off of my workbench, etc., etc. But that's not going to happen until hopefully sometime next week. But anyway, that's next week's project, not this week's project. In the meantime, I am done in here today. That's all I got to say for a while. I am out of here. Hey, thanks for watching. Please subscribe. Free set of connecting rods in it for somebody when I hit 100. Hey, take it easy. Thanks.